Okay, so I'm going to review a couple of things that we talked about in class today, some things we talked about in class on Friday. These are going to be on your quiz on Tuesday, and this is just to kind of reinforce what we went over. First thing we did was look at a regular sphere and find the volume of a sphere. So the volume formula for a sphere is 4/3 pi r cubed. And in this sphere, you can see that right there is our radius. So I'm going to do 4/3 pi times 10 cubed. Now I'm going to show you how I do this in my calculator so you can follow along in that as well. So when I use my Inspire, I do 4/3, and I put parentheses around it. And then I'm going to put my r, and I use the caret button, cubed, and click enter. Now you can see it gave you a fraction, and I know that's going to have pi on the end. You can either use that fraction, or when I enter this, if I go over to the 10 and I put a decimal after it, it will give me a decimal answer. So 1333.3 is going to be my answer. And I know there's the pi at the end. That's the volume. Now we've done that. But what might be new to you is a problem that looks like that. Now, some of you may be able to tell right offhand, but this is a hemisphere, if you remember that vocab term. It is the same sphere that we have here, but it's been cut in half, which makes it a hemisphere. Okay, so if you think about it, it's half of that sphere that we just found the volume of. So if I were given this problem, I do the same thing that I do for a sphere, but I'm going to take half of that because it's half of that sphere. So I've already done this part, and we know we got that for our answer. I'm just going to divide that by 2, which I still have it in my calculator. So I can go ahead and just click my answer. Sorry, I'm doing this in my calculator. Divide it by 2, and the volume of this hemisphere is that. The next problem we look at looks kind of funny to you, I'm sure, but it is just some shapes that we have done individually. We've got a hemisphere, we've got a cylinder. We know how to find the volume of each of those. So that's exactly what we're going to do. We're going to find the volume of this hemisphere, and I'm going to add it to the volume of this cylinder. Okay, so I'm going to set up my work nice and pretty. I'm going to take my hemisphere volume plus my cylinder volume. Hemisphere, I know that I have to take half of a sphere. The cylinder is going to be base times height, but I know that base is going to be pi r squared because the base is a circle. So then I can fill in my numbers. My radius is 100. And now my radius on the hemisphere is exactly the same as the radius on my cylinder. It will always work out that way. If I had a cone on top of a cylinder, the cone would have the same radius as the cylinder. So then the cylinder formula, I use that same radius, square it, multiply it by the height of the cylinder. So then I enter that into my calculator. For this part, I get 666,666.7. And for the cylinder part, get 1,500,000. So then I add those two numbers together. And that is my final answer. So anytime you have what we call a composite shape, you're going to find the volume of each and then add it all together. Okay, on Friday we talked about similar figures and their surface area and their volume and the ratio of those. This is one of the problems that we worked on Friday on your worksheet. You may not remember, so that's the reason I'm going to go over a few of these. If I want to find the scale factor of these two shapes, I take any two corresponding sides and I'm going to set up the ratio. So I'm going to put small over big and I simplify that. It simplifies to 1/2. We always want to start with our scale factor ratio. To get to my surface area ratios, I'm going to have to take this number and square top and bottom. To get to my volume ratio, I go back to this and I'm going to cube it. So I take 1/2 to the third power, which is 1/8. Now, if we go to our calculator, remember the way you're going to raise something to a power, I'm going to put my fraction in, and then this little caret button right there raises it to a power. You can see we get what I calculated on the smartboard. Then we did some problems where they give me the scale factor and I had to find surface area and volume, the missing pieces. And this, I knew to find the missing surface area, I have to take my scale factor, and rather than using that, I have to square it. I use this to set up my proportion. So small over big. The directions told me this was the small surface area. I'm trying to find the big surface area. So I cross multiply, then divide, and I get my missing surface area. When I'm finding the missing volume, I have to take my scale factor, and this time I have to cube it. So I'm going to get 9 over 125. The small volume was 2,592. I want to find the big volume. And I get 36,000 cubic centimeters. The other thing I wanted to review with you is if they give me, I'm going to come back to that. If they give me two volumes, okay, let's say they gave us those two volumes. This one's obviously the small volume. This is the big volume. And I just want you to find the scale factor. The way you have to do that is you're going to set up your ratio of small volume over large volume. And what I'm going to do in the calculator is take a cube root. So I'm going to go back to my calculator and I'm going to enter the fraction without the pi. Actually, let's go back. First thing I need to do is set up my cube root. So you do the control caret. I'm going to be taking a cube root, so I put a 3 there. Then I arrow down. Now I put my fraction in. Click enter, and it's going to give me that ratio, 125 over 216, the cube root of it fully simplified. Gives me 5/6. That is my scale factor. Now if I then needed to find a missing surface area, I would do exactly what I did back here when I took my scale factor and squared it and used it in a proportion. So let's do one more example problem. I've got to find a missing surface area and a missing volume. So the first thing I'm going to do is set up my ratio. Okay, but I want a simplified fraction. So I'm going to go over to my calculator and enter 7.5 divided by 15. I did not mean to do that. Okay, here we go. It gives me 0.5. Well, we know what 0.5 is as a fraction. It's going to be 1/2. That is my scale factor. Okay, I don't want to use 0.5. I actually want to use the fraction so I can set up a proportion. So small over big. But what do I have to do to get surface area? I have to square that for my proportion. So small surface area over large surface area. I'm missing my small surface area. This is my big surface area. So I do 240 times 1 equals 4x, so then I'm going to divide by 4. Now I did not enter my pi button on anything. I just held off on that and knew that at the end I needed to have pi. To find the missing volume, I have to take my original scale factor and cube it. So I get 1/8. That's the scale factor I want to use to find my missing volume. So I don't have the small volume. That's my big volume. I cross multiply, and I get 15 pi for my small volume.